Alright, today we have another geology lesson, as the program we're watching is called Rocks That Form on the Earth's Surface, made once again by the Encyclopedia Britannica Films, a production company we are well familiar with by this point. And this was published all the way back in 1964. Okay, so Rocks That Form on the Earth's Surface from 1964. Are we ready for this? Let's dive in. So even before we get started, I just want to say that I'm kind of curious about this because I'm thinking about it and I'm thinking all the rocks that I know are formed below the Earth's surface. So I'm curious about the rocks that actually form on the Earth's surface. Is that going to be like specifically oxides or something? I don't know. So let's dive in. Okay, so EBF AGI Earth Science Series. Yeah, so we learned actually in the first video of this week that these sorts of programs were sold or rented to schools to be watched in the classroom. So now we know in most cases a teacher just put this on for her classroom of students to watch. So that's the mindset that I'm trying to put us in right now. Rocks that form on the Earth's surface. Yeah, there you go. I feel like this could be a green and not a blue, but geology to me is a blue, so that's what we're going with. Like we're on a boat, right? Like it's a blue. Okay, yeah, produced by the Encyclopedia Britannica and the American Geological Institute in collaboration with John S. Shelton. I feel like that is a name we've seen before. John S. Shelton, PhD Chief Advisor? Maybe not though. Producer Stanley Kroner, Director Charles L. Finance. His last name is actually Finance. That's funny. Dude, this up-close shot of this kid taking the jar out of the water, like, talk about a slightly unnecessary shot. Like, it's a good shot, I don't get me wrong. It's just like, in an old program like this, it's so funny when they go the extra mile to, like, actually make their actions cinematic. Like, how many shots did we just see for this kid to take a jar out of the water? Like, there were like 4 or 5 shots in there, at least.
If you dip a jar of water from a muddy river, you will see bits of mud and sand settling to the bottom of the jar.
Yeah, I think this is still true today, too. This is not only true back then.
Where did the mud and sand in the river come from?
Where did the mud and the sand in the river come from? Let me see if I can answer this. Well, it came from the eroded bedrock, right? That's all I can say.
Since the river is bringing the mud and sand downstream, the logical place to look would be upstream.
Yeah, upstream to the mountains, that's where it all came from. It's all just material that's been eroded from mountains somewhere.
Here in the high country, the source of the river is a small, swift creek. Mud, sand, and small pieces of rock are being picked up and carried away by the current.
Dang, good for them for getting these shots of like natural collapses going into water. Again, I don't know if these are actually like natural collapses. Like, what are the chances you're aiming your camera at this cliffside just as like a little bit of it crumbles off into the water, right? Like, these had to have been staged or like planned somehow. I don't know how exactly you'd cause a rock slide remotely, but like, I'm pretty sure that's what's going on here. It seems too lucky to just get a shot like this without making it happen on your own.
But where do mud...
Right, like how do you actually make that happen? It looked like that was forced, but like how do you make that happen? I don't know.
Sand and broken rock come from? Look around you. Everywhere you can find things that are slowly crumbling into bits.
Dang, I like how the example of like rocks breaking down and eroding is like the sidewalk, you know? Like not even like regular rock, like their sidewalk is just crumbling into the rock of this river. That's funny. And again, this is 1964 and they already have like crumbling infrastructure. Like weren't these roads built like 10 years ago? Like why are they already crumbling like this?
They are gradually decaying and decomposing from long exposure to the sun.
Again, all of that was like paint chipping off of something. That wasn't like the rock actually being eroded. And this is all rust. I mean, I guess rust is a form of rocks eroding. So I guess that one's fair, but the paint chips, that's not really erosion.
Heat, cold, and wind.
Yeah, these like that's not erosion, that's just paint peeling. I don't know.
They are weathering.
It's so funny that they're treating like this human environment, like these human things as like natural rock. Like how does the sand in the river get made? Well, sometimes things rust off of like your boilers at home, you know, like no, most of the material comes from the native rock. That's the bedrock of where this is, you know, it's not human made things that are becoming the sediments. That's a very weird and specific example to be giving.
In nature, weathering has a similar effect on rock.
Oh, okay, so that was just an example, and now we're applying the example to the actual situation. That's good. So now, okay.
The rock gradually decomposes. It crumbles into small grains of mud and sand, and gravity pulls them downhill.
I feel like that could have used like a better visual. Like we could have actually seen a rock being broken up. Like I feel like a kid needs to see that in order to understand it. Maybe not, but like I would have appreciated that visual at the very least. And I guess that means I'm just a dumb kid.
Eventually, most of the mud and sand is carried into a stream. When rocks freeze and thaw over and over again, cracks develop.
Yeah, see, I feel like this is another thing that like a visual could exemplify nicely, but I guess here we are.
Occasionally, a piece of weathered rock breaks loose and gravity pulls it downhill.
All right, so here's the question. Was that a real shot, or did somebody like just chuck a rock off the cliff and they filmed that falling and breaking? You know, like how do you fake that shot if not having somebody at the top to chuck off a rock? You know, I'm pretty sure that's how you film something like that. But honestly, that rock looks a bit too big for somebody to pick up, so maybe I'm wrong. Jeez, and it's coming right at the cameraman. Like that was a little sketchy there for a second. Like this tumbling boulder coming right towards us. I guess he was on the other side of the river. Okay, but even still, the cameraman definitely got wet from this.
Tumbled by the current, rocks are further broken and worn into smaller and smaller pieces. All that finally remains...
This is really good photography, though. Like, they must have figured out a good way for shooting stuff like this, because you can't get shots like this just randomly. Like, you have to be very intentional about getting shots of a collapsing river, you know? Like, you have to know exactly where and exactly when to shoot, or you have to find a perfect place for you to create, you know, conditions of your own.
Of a weathered rock is mud and sand. These bits of decomposed rock are called sediment.
Sediment. You know, I appreciate that they're giving us like text on screen. That is a luxury that we very rarely get in an old program like this. So I appreciate it. Even though I already knew sediment and I already know how to spell it, like I appreciate it nonetheless. See, that's the thing. In a classroom, all the kids are writing down sediment. Like, oh, what is sediment? Oh, what do you call all the rocks? You know, like that's a quiz question right there for you. Don't worry, guys, there's not going to be a test this time around. Or will there? Maybe there will be.
Sediment along the banks of a river may remain in one place for many years, but sooner or later the river picks it up again and carries it downstream.
Yeah, I feel like maybe the most important concept that they haven't communicated in this program is just the idea of like geologic time. You know, like to a human's perspective, like a rock being caught at the bottom of a river, it's just going to stay there forever. It's never going to erode. But on the scale of geologic time, that's not true, right? You have to understand that like time is so vast and has gone on for so long that even the rocks that get caught at the bottom of the stream eventually get dislodged and continue to travel downstream. You know, like that's the most like foundational information like of geology in total really is geological time. Yeah, the understanding that the earth is very old is like core to understanding all the geologic processes on this planet. So that's something that they could have mentioned, but you know, I'm not going to fault them for not mentioning it.
When one river joins another, a larger river is formed, and the combined load of sediment is carried away. Eventually, most sediments reach the relatively calm waters of an ocean.
Oh, this is a cool shot, actually. So you can see the sediments suspended in the water, right? So you can see this blue water, that's the ocean water, and then you can see this brown water and a very, very clear line between the two. This is a very good shot for illustrating suspended sediments in the water.
The stream's current doesn't extend very far out into the ocean. What happens to the sediments now that there are no longer any strong currents to move them?
Yeah, well, now they settle on the sea floor and they build up into large flat platforms of sediment, which eventually become stones. Okay, so that's, yeah, okay, so I just put it all together. So that's what we're learning today, is we're going to learn how these sediments get deposited year after year after year until they form into a sedimentary rock. That's where the name sedimentary rock comes from.
It's hard to tell here, since whatever happens takes place under the ocean. It'll be easier to find out in a man-made reservoir.
Oh, this is cool. So we're actually getting to see, like, behind a dam. That's real sick.
A stream has been carrying sediments into this reservoir for about 30 years.
30 years. Wow, interesting. So this reservoir was made in like 1934. Oh, that actually checks out, right? Because that's like the Great Depression. That's when we were building like dams everywhere. So that's funny how that actually makes sense.
If the reservoir is emptied, we can find out what happened to the sediments.
Where is this? Does anyone recognize this reservoir? This looks like somewhere out west to me. This does not look like the East Coast at all. So I'm curious if anyone more familiar with that side of the country can tell where this actually is. Dude, this guy has my exact hairline.
The sand and pebbles have settled out in nearly horizontal layers.
See, this is awesome too, yeah. Getting to see the actual like layers of time go down, that's cool. That's like year after year of sediment deposition here.
But why? The sediments were carried into the full reservoir by this stream. What happened to them when they reached the calm water?
I feel like I said this already, but yeah, the sediments settled to the bottom because the water wasn't moving fast enough to keep them suspended in it. So that's what happens. The water flows and it carries its sediment load until the water slows down and the sediment load is dropped off. That's what happens.
This is a simplified model of a stream.
Dude, this is a sick model right here too. I wish I had this sort of stuff in my class, or for my videos as well.
Flowing into a reservoir. The water running down the canyon represents the normal flow of the stream.
See, this is just so cool that we're getting to see like a physical example of this happening. I don't know. We're so lucky that we get to watch stuff like this.
As in nature, the stream brings down...
See, like, this is so much better than, like, an animation or anything. Like, this is the sort of stuff that, like, I do wish I did more of on Atlas Pro, is actually have, like, a physical example showing you how sediments build up. Like, that's what we're seeing right here, right before our eyes, is the sediment mound building at the mouth of this river. It's so cool getting to see it happen physically for real right in front of you. This is way better than any animation ever would have been at explaining this process. And yeah, you actually get to see how it works. Like, that's what's so cool about it. You get all the complexity of the action, you know? This is real cool.
When the stream enters the still water, the current slows down and the sediments settle out.
That exactly what I said.
As the stream shifts its course, the sediments are delivered to a new place. Later, the stream has changed course again.
See, this is cool. I kind of wish we got like a time lapse of all that happening. I wonder if it really happened for real or if they just, again, staged it all. Because it would be really cool to get to watch like the meandering of the river's end.
And so it goes. The stream delivers different mixtures of sediments at different times and places.
Dude, but these shots, I love these shots because they really do help illustrate like the infinite complexity of a system like this. Like seeing every single little grain go exactly where it needs to go based on the speed of the water and everything. It's so fascinating. It really does illuminate this process so much better than an animation or just a plain explanation ever would have. Yeah, this right here is like the strength of like video educational programming, is like we actually get to see things that are so impossible or take so long to form usually that we don't get to see it. Like we're getting a special insight into a process of the earth by getting to watch this.
And they accumulate on top of each other.
And this is so cool. Now we can see like the whole river delta has formed. Like this is, oh man, this is so cool. I know I keep saying that, but it really is.
What is the result of this constant change? The sediments have been deposited in layers like those in the reservoir. The sediments that are carried into the calm waters of the oceans behave in a similar way.
Yeah, see, that is a great example to show right before showing this. See, this makes a lot more sense. See, these shots from above make a lot more sense once you understand that all of this sediment is settling out into like a delta fan or something.
They settle out in layers in the shallow offshore waters. But the sediments don't always stay in place. This is a sand slide in the ocean off the California coast.
Wow, is that real? We're watching a sand slide taking place underwater off the coast of California? That's nuts. Like, I guess it makes sense that sand slides happen. I never really thought about that, but like, I guess that's an underwater landslide for you. Even that is very interesting.
California coast. Sand that may have started its long trip downhill from mountains hundreds of miles inland.
Yeah, this is crazy. We're actually seeing like sediments fall off a cliff into the deep ocean. This is like the edge. This feels like the edge of like the continental shelf or something. It might not be, but like that's what it feels like.
Is still being pulled downhill by gravity.
It is crazy that like the sand falling through the water kind of just looks like flowing water, you know? It's like it flows in a similar pattern to how water flows when it's in air, which I guess makes sense. It's all fluid dynamics at the end of the day. It's interesting that that's how it looks to me.
And there are still other ways that sediments move.
Dang, so I wonder if there are like sand waterfalls in the world, you know, or sand falls. I guess sand falls. That's yeah, that makes more sense. So I wonder if there are like just perpetual places where sand is like falling off of a cliff because a river is just constantly adding sand to a delta plain or something. It's very interesting. I'm very much enjoying this footage. This is something that is totally unexpected.
Towards the depths of the oceans. This tank represents a small cross-section of the ocean.
Dude, this is like some real practical engineering stuff. This isn't real engineering. This for sure is practical engineering right here.
Ocean floor and includes several hills and valleys.
This is sick. I love the little miniature recreations too. These always do such a good job of illustrating the concept. I'm already so excited for this demonstration.
The unevenness of the bottom is exaggerated to make the results of the experiment easier to see. Let's watch what happens when we release a fine-grained sediment into the tank.
Man, this is so cool. I'm so excited already. This photography right here is just so cool. Like we're actually watching like, I don't know, fluid dynamics right before our eyes. It's just, I wish I had better ability to describe why what we're watching is just so cool and interesting, because like that shot alone, that one shot was just so cool.
After several hours, the sediment has settled to the bottom and formed a layer.
Oh wow, that's really cool. So the sand is a different color, so you can actually see where it piled up too. This is awesome. This is like really enjoyable right here.
The layer is not quite horizontal because of the exaggerated unevenness of the bottom.
Yeah, see, this is always what I've been curious about too, is like how exactly do they settle on these like uneven grounds? And you can see they only settle in the low points, never the high points. Obviously, that makes a lot of sense. It's just like, I don't know, it's so cool to see it physically happen.
Another load of sediment released into the tank will form a second layer atop the first. In the
Dude,
oceans,
like even that shot, that's just, I don't know, maybe it's just like how cool does sand look underwater? Maybe that's what I keep falling for, but like these shots are really cool.
such a layer may be only an inch or two thick.
And yeah, the fact that they fade into like the future to show the layer that is formed from the cloud, that's like, again, that's an impressive shot too.
And may extend for many miles. It might lie undisturbed for centuries before another mass of sediment is loosened nearby, perhaps by an earthquake.
Dude, this like tracking shot of like the wave, the sand wave entering the basin, this is sick. This is, oh man, this is so cool.
But then the new flow of sediment will cover the original layers and form a new one on top.
Dude, yeah, this is so, I keep saying the same thing, but this really is doing such a good job of illustrating the lesson that we are trying to learn right now. Like, we are getting to physically see each layer take shape right before our eyes. You know, it's just like, this is so special.
In this way, layer after layer of sediment is deposited on the ocean floor.
See, I'm curious if each of these layers was an actual like releasing of sediment and letting it settle, or if they just like made these layers after the fact in an easier way. They might have just done it all authentically, but it's just, I'm curious. I don't know. But it just seems like a lot of work to do all these releases. It's releasing sand in like a tub, so I guess it's not that much work. It's impressive to think that they did this experiment, how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They did this 15 times in order to get this imagery for us. Like that's impressive. That's a lot of extra work, you know?
The sediments will first fill in the low places.
And yeah, you get these great like profiles of the different like changes in elevation. Like, oh, this is real cool.
Once these have been filled in, the layers deposited on top are horizontal, even though the bottom of the tank was not. So it is that when sediments are carried into an ocean or any body of calm water, they settle out in nearly horizontal layers. These layers resemble the layers of loose sand we found in the reservoir. But this is hard.
You know, that has always amazed me. Like, not the fact that the sediment builds up, but that somehow the sediment cements into itself to become a rock. Like, that's what's crazy to me. Like, how does sand become a solid rock? You know, like that's always what blows my mind when considering this process.
Rock. What made it hard?
What made it hard? I have to imagine that the pressure is what made it hard. Though it's hard because they're talking about like a 30-year-old like basin here, right? Like maybe not, maybe they're talking about regular rocks, but like I don't know, a rock doesn't form over 30 years, you know? Like those sediments would still be loose by that point. Like this is a much older sedimentary rock right here. Or at least I have to imagine it is. I could be wrong again, but like I can't imagine this rock face was formed in 30 years.
Could the pressure of many tons of rock lying on top have had something to do with it?
See, yeah, exactly. You need more rock on top in order to create the pressure that forms the aggregate or the rock on bottom. I don't know. It's just, yeah, I don't think these are 30 years old.
This is a sample of a natural sandy sediment. Let's see what happens to the sediment.
Oh, they're actually going to turn it into a rock? This will be cool. If they actually do, this will actually blow my mind. If they turn this sediment into a rock, like right before our eyes, like, wow, that'd be cool.
When we put it under a hydraulic press.
Oh, wow. So yeah, they are going to turn it into a rock. I thought he was going to do it with his hands. But yeah, if they're putting it under a press, like they're going to make a rock for us.
And apply 15 tons of pressure.
15 tons? That's all it takes? I feel like that's not actually a lot. When you consider like rock being buried by like another mountain of rock, 15 tons isn't very much weight. That's interesting how the hydraulic press went up instead of the head going down. I don't know. Oh no, that was a good shot. I have to give some appreciation for that shot. The zoom in of the dial on the hydraulic press from all the way. The what is it? A smash zoom? Is that what it's called? Like the sudden quick zoom in. That was a very energetic shot just to show the meter of this hydraulic press. Dang, that was an interesting way to introduce this little thing. They dropped it down. So they set up a camera looking at a table and then they dropped it just to introduce us to this little puck that they made. Again, this is just like an interesting choice of camera placement and like how to tell this story. Wow, that is fascinating though. It really did just turn into a rock. Like I guess that is all it takes is just pressure and like material.
Pressure does help to make hard rocks from loose sediments, but the change is not complete.
Oh, that's interesting. So yeah, it didn't form a totally intact rock. I guess it might need like water or like maybe just time. Maybe you just need time for like more crystals to form or something.
Something else must be needed to turn sediment into true rock.
Is it water? Is it like a solvent or something? I don't know.
Let's take a piece of natural sandstone into the lab and examine it.
Oh, this is cool. Oh man, we get to see this guy's like circular table saw too. That's like, that's so cool. I guess this guy's a geologist, right? Like he has a circle saw just for this purpose alone.
With a diamond saw, a thin slice is cut from the rock.
I like how we got like 3 or 4 different shots of this guy just cutting one rock. You know, again, it's that old form of editing style where it's like, let's just show them the whole process take place.
One side of the slice is ground and polished. The slice of rock is then attached to a glass slide. Further polishing grinds the rock down until it's about 1/1000 of an inch thick.
Oh, wow. So that's interesting. So yeah, they glue a glass pane onto one polished side and then they sand the other side just so that they have like a very narrow cross section of this rock. That's interesting. They probably sand the other side so that they can actually get light to come through it so that they can actually look at it under a microscope too. That's like, I'm pretty sure that's why they did that.
Finally, a protective cover glass is mounted on the thin section. We may then study this thin section under a microscope.
Yeah, there we go, there you go. Like, look how thin that little sheet of rock is. That's crazy. Like, imagine how thin you have to create a layer of rock so that light can penetrate through it, you know?
Polarized light helps reveal...
Oh wow, is this the magnified... This looks like a shot of like a cliff, not like a microscope shot of like sand sediments. That's interesting. I can barely even see what's going on here.
The different kinds of particles of which the rock is made. We can see several different kinds of sand grains. But what is the material between
that little like outline? That was funny. I couldn't really pick apart any of those sand grains that they outlined for us. Like I wouldn't have, I don't know, like that's just, that wasn't obvious, I guess. Those obvious sand grains they highlighted weren't so obvious to me.
That seems to be holding them all together. And how did it get there?
Okay, so interesting. So the dark things are the sand grains, and then this light stuff is like the lattice that holds it all together. So what is it? I guess it's probably like clay or something, right? Or no?
This irrigation pipe on a Nevada ranch is supplied by underground water from a nearby well.
Huh, so they're not going to just tell us. They're going to tell us a whole story now. That's interesting. It must be like calcium carbonate or something.
Over the years, the water has
Oh, maybe it is. Oh, that is interesting, actually. It might be the dissolved minerals in the water precipitating out on the surface of the sand grains until they form a secondary lattice between all the sand grains. That is interesting. I bet that's what it is.
Deposited a white crust on the pipe. When we drop some acid on the crust, a fast bubbling reaction takes place. This bubbling reaction indicates the presence of calcium carbonate.
Calcium carbonate. Wow. Wow. You know what? That's another pat on the back for me. I called that, I think. Did I say calcium carbonate? I think I did. Maybe not. Maybe tell me if I did or not, actually. I don't know. I don't specifically remember, but I feel like I did say calcium carbonate. Yeah, okay, so it is the dissolved calcium carbonate and other sort of salts in the water that precipitates out and forms another solid in between the sediment grains that forms one solid rock. That's interesting. Wow. Oh yeah, look, they're next to a cactus. This looks like prickly pear or something. So yeah, they must be in the American Southwest somewhere.
This rock is in the hills just above the ranch with the crusted pipe. If acid is dropped on the rock, again a bubbling reaction takes place.
I like the idea that this guy is just running around dropping acid everywhere. I mean, dropping acid on rocks and stuff. Oh, you know, well, yeah, whatever. Yeah, he is just dropping acid everywhere he goes.
There must be calcium carbonate in the rock. Could water have deposited calcium carbonate in the rock, as it did on the pipe?
Yeah, so calcium carbonate dissolves into water. So that's what we're getting at. I'm pretty sure I figured it out. Yeah, the materials dissolve into the water and then they dissolve back out when they enter the sediments. Interesting.
A lab demonstration can help answer this question. We'll use some loose sand and cover it with a chemical.
That's probably the funniest slide I've ever seen prepared for a microscope. It's just like a bunch of sand put on it, you know? I don't know. If you work with microscopes, let me know if you've ever seen a worse slide for your microscope. It's just sand. Like, because you have to wedge it between the panes of glass. So like, that seems like it would be really annoying to like prepare slides for. Like if one of those grains is just like too big, you might like split the whole pane of glass.
Chemical solution representing calcium carbonate. Let's watch what happens under a microscope.
So yeah, the calcium carbonate is going to form like a very thin film or layer on the outsides of these sand grains. And eventually that over and over again for years and years will create a lattice or a filler of the materials that holds it all together.
With the time-lapse camera, we can condense an hour.
Oh wow, time-lapse footage? This is going to be real cool.
Into a few seconds.
That's so funny how the grains move. Even on their own, they're moving. You know, like the water and the evaporation of the water. It's crazy how it's all moving on its own, you know? Oh wow, you can see the lattice forming in this corner though. That's awesome. Like the crystal lattice, wow.
Crystalline material gradually grows in the spaces between...
Wow, yeah, this is exactly what I was thinking. This is so cool getting to see this, actually. Again, this is like, we're getting to see it up close. Like, this is so cool. It's like, there's no YouTube video equivalent to this, you know? Like, this is just really cool, awesome footage that just doesn't exist in an educational form anymore. So, like, it's so special that we're getting to watch stuff like this.
Between the sand grains, cementing them together.
Like we're seeing like a rock being formed under a microscope right now. Like pretty much like that's what we're seeing. We're seeing geology take place. Like we're witnessing geology right here. This is the act of geology. We just witnessed this rock have a geology.
This is similar to the way the grains of...
Wow, I want us to appreciate that shot like just once more. Like that was really cool. Like I hope we get another one of those.
...sand were cemented together in the hard sandstone. Calcium carbonate cement must have been dissolved in underground water to seep through loose sediments for many centuries, cementing them into rock. Rocks made from sediments are common, and they are always layered.
Yeah, now we just got like 10 seconds of like B-roll stock footage of rocks with nothing happening. Again, another little like slow editing choice. You know, I do appreciate some of these shots, though. Some of the shots are good, just at illustrating the point or the idea that the narrator said, but some of them feel unnecessary.
They have been formed from loose sediments which have been pressed and cemented together over long periods of time to form hard sedimentary rocks.
Oh man, I feel like we've seen like this exact map before. Oh, I mean, you know, it is Encyclopedia Britannica, so maybe we have seen this exact map before, but I feel like I'm familiar with this like textured map now.
In this part of North America, sedimentary rocks make up over 70% of the
Oh
land.
wow, this is a cool map actually. This is like the first time I've seen a map like this in an old program where it really does try to include every single little fragment of sedimentary rock deposition, you know. This is cool. So you see over here on the East Coast, this is not the Appalachians or the Appalachian Mountains. This is, I think it's called the Piedmont. If I'm correct, this is like the Piedmont area. This is the deposition of all the rock that eroded from the Appalachians or the Appalachians. I say Appalachians, people say Appalachians, it's whatever. But this is the Piedmont area, I think, over here. And then you have over on the west all these other areas of deposition that I'm not as familiar with. But this is interesting. This is such a sick map. This is like the exact sort of map I would use for one of my videos. This reminds me a lot of my biogeography of caves video. It's a slightly different rock map, but it's a very similar idea, at least.
The land. Was all of this rock made from bits and pieces of decomposed rock? Or was some of it formed from other kinds of sediments?
Other kinds of sediments. That's interesting. What other kinds of sediments are there? I guess there's like lava, right? I don't know. What other, besides, I don't know.
These are shells of animals that...
Oh, yeah, okay, so living things are also sedimentary. Okay, that makes a lot of sense. I actually made 2 whole videos on this over on Atlas Pro. It was part of a series. Yeah, these fossils are very familiar. These bivalves, like this is cool. I'm in familiar grounds again.
Animals that once lived in the sea.
So yeah, these sea creatures also built their shells out of calcium carbonate. So when they died, all their calcium carbonate shells piled up on the ocean floor, layer after layer after layer of carbonate shells until it formed one cohesive calcium carbonate rock pretty much. Or at least that's what I imagine they're getting at here.
Over periods of thousands or millions of years, as these creatures died, their shells collected on the bottom in layers along with other ocean debris.
Yep, exactly what I said. Just layer after layer of shelled creatures dying and building up, calcium carbonate deposits on the ocean floor.
Eventually, the shells and other materials became cemented together to form the sedimentary rock called limestone.
What's interesting about limestone, though, is that because the material is actually the same material that forms the lattice structure in other sedimentary rock, that limestone is just entirely limestone. Those other rocks had sand, and the thing that held it all together was the calcium carbonate. But in limestone, it's all calcium carbonate. The shells are calcium carbonate, the lattice is calcium carbonate, it's all calcium carbonate. So it forms a very solid rock compared to other sedimentary rocks.
This coal mine in West Virginia...
Dude, why do I feel like I've seen this exact same stock footage of the West Virginian coal mine? This stock footage of this coal mine, I feel like I've seen this every time I've heard West Virginia mentioned as a coal mine. Am I the only one? Do any of you feel like you recognize this one stock footage shot as well? I don't know. Let me know.
...is deep under the surface of the earth.
See, this is so cool. We're actually getting to see mining. I know that sounds so silly, but how often do you actually get to see the process of mining coal take place? We're getting an inside look at what mines were like back then. Look at the machines they were using. They're just carving through this rock. I thought it would be harder, but apparently not. They're just cutting through it like butter. Wow.
We don't find any pebbles or...
Wow, they really are just cutting straight through this rock. I was not imagining that it was this easy to mine coal.
...seashells in this mine, but sometimes we do find the impression of plant leaves. Normally, Leaves and other plant materials that fall.
Oh, that's funny. So now we're talking about plants. See, that's a very specific moment of sedimentary rock, right? Because if they're referring to coal specifically, then we're talking about the Carboniferous period when there were no bacteria capable of breaking down the long chains of molecules that were forming in the plant's bodies. So there was a period where plant material like this simply could not be broken down by anything alive on the planet. So instead, it accumulated in huge, large mats on the ground and, eventually became coal deposits. So that's interesting. That's interesting that we're talking about coal as a sedimentary rock, because that's very rarely referred to, or at least in my mind, I never think of coal as being a sedimentary rock, but I guess it is. I guess that, that's funny.
Fall into a pond or swamp will settle to the bottom and decay in the stagnant water. But not always. If mud and sand are washed into the swamp, new sedimentary layers will accumulate.
It is funny. It's funny how they're explaining this without explaining like the aspect of the Carboniferous not having bacteria to break down the materials in the plant. Like here, they're just suggesting that the plant material gets buried and then that saves the molecules for later to be turned into coal. But I'm pretty sure there wasn't even bacteria to be breaking these things down anyway during this time, or at least for a period of Earth's history. This sort of thing still does happen to this day. I would not say this is how most coal was formed.
When great masses of plant materials are trapped and pressed down by tons and tons of overlying sediments, the plant materials may change into the sedimentary rock called coal.
Yeah, see, I really just did not associate coal with sedimentary rock. But yeah, I guess it is. That's just another thing I never really would have thought about had I not watched a program like this.
And like other sedimentary rocks, coal is always found in layers. This coal mine...
Wow, look at this machine. This is crazy. This is like a little crab. It picks up... That's so funny. It picks up... This is like an actual biomimicry of a crab right here. That's so funny.
Mine is over 1,000 feet under the surface of the earth.
Like, even as it works, it looks like a crab. That's so funny. Do we still use machines like this? I have to imagine there's a better way of loading rocks onto a conveyor belt than this, but I can't think of any. So yeah, if anyone works in a coal mine still, let me know if we're still using machines like this.
Why do we find the impression of a leaf this deep underground?
See, I wish I could find a fossil like this underground. Like, I would be so excited to find something like this.
Why do we find seashells high up on a mountainside?
Dude, I literally made a whole video about this. I know I said that already, but like that question specifically was the video, Like, oh man, like, yeah, go watch the video. If you want to watch this, that's what's so interesting about these old programs is I tried my hardest to make my own educational video answering this exact question. And here we are asking it in this program as well.
And why is rock that was deposited in horizontal layers underwater now tilted high up in the air?
That was a cool camera move too. I wasn't expecting that at all. I actually did think the shot was already leveled. So that was cool. Good for them. Hang on, so they're just gonna finish that with a bunch of questions? Like, I guess this was for a classroom of students. Maybe the students had to like write their responses or something, but like, it seems weird that we're just being left on a cliffhanger like that. Oh, like a cliffhanger. No way. But yeah, like, I don't know. I'm going to go back and I'm going to answer those questions for us, actually. How about that? So the first question was, how did these fossils get all the way onto the top of the mountain? I made a whole video about that. I'm actually not going to answer that here because, yeah, go watch my video on it if you really want to know the answer to that. But how did those horizontal layers turn vertical? And that is because of plate tectonics. That's because of two things ramming into each other and then deforming, right? We're getting to see the deformation of the Earth's crust when we're seeing, formations like this. So that's how horizontal layers end up vertical or almost vertical, is because of the deformation of the crust as a result of tectonic activity. So that's my answer. We don't have to wait for the teacher to tell us, I guess. Oh, maybe I should have made that our quiz. Dang. So I guess there really is no test for you guys. Dang. Oh well. Maybe next time. I'll test you guys next time. Okay, hang on. So it has the photographer. It has I. Mankovsky. Okay, I. Mankovsky and P. Limbach. Okay, those are the photographers. I. Mankovsky and P. Limbach. Shout out to them for all those good shots. I feel like I mentioned their work a few times in this. So yeah, they deserve it. And then editing, T. Boutros. All right, so this guy, this is the person who made some of those funny decisions. So, I always like looking at the credits. I always like giving these guys the credit that is due to them. All right, so that was very fascinating. I actually feel like this, although I feel like I already knew a lot of the foundational knowledge, I feel like this did help fill in, like, not the gaps. It literally was the calcium carbonate to my sediment load. Like my brain was a load of sediment, and this helped, like, fill in the gaps between the sediment. Does that make sense? I think that's actually a really good metaphor. I'm actually pretty proud of that. But like, I didn't learn too much like very significant information, but I did get to see some very interesting scientific processes take place. And now I feel like I actually do understand sedimentary rock better now. Like I really do think I have a better understanding of geology from watching this, which obviously that's the point, right? But I feel like in a lot of these, I don't actually end up learning that much. But in this, I actually like getting to see those shots of the rock lattice forming between the grains. Like that's the real sort of thing that I need to have in my head so that when people ask me, how does this stuff work? I actually know exactly how it works. I know what it looks like for these rocks to form because I watched this. So this was really enjoyable. I do feel like I gained a lot from this, actually. This was a lot of fun. And I know I always say that, but for this one especially, I do feel like I actually did learn a little something, or at least I learned how something looks at the very least. No, I'd say I learned a lot. I'd say I did learn like quite a lot of good information from this. This is definitely something I would approve of showing a classroom full of kids. Like this is definitely going to inform children on how sedimentary rock is formed. Like obviously that seems dumb to say too, like that's the whole purpose of this program, but it really did accomplish exactly what it set off to accomplish. So like, yeah, mission accomplished here. So yeah, now we know rocks that form on the Earth's surface. Yeah, that was the real strength of this program, is all the little demonstrations they had. Like seeing these grains of sand form the river delta, that was really incredible. Seeing the calcium carbonate expand through the sediment, like that was again another, I will remember that actually for the rest of my life. Like I now fully understand sedimentary rock, I feel like. Maybe not fully, but I have like a very good model and understanding of sedimentary rock in my head now because of this. Whereas before, I understood sedimentary rock, but I didn't have like the same visuals. So this actually did like help educate me in this subject. So I'm really happy with this. I really enjoyed this. I really think we got as much as we possibly could out of it. So I think that's where we are going to end. And let you know that if you enjoyed watching this and would like to help support me and this channel, you can follow the link in the description that'll bring you over to the Internet Archive. The Internet Archive is where I get all these old programs from. So if you want to support me, donate to them. And with that, we're ready to cut to black.